Hello friends, in this section we will be considering the loading applications, analysis and design of this small bridge. So stay tuned as we proceed, and once again you are welcome. Let's start. I want to be looking at the imposed load once again on this structure. You will have to first of all determine the type of vehicle that may be plying this particular structure. If I select my slab right there and I right click, I check the property of the slab. I go straight away to the loading tab in the slab dialog. Sorry, I activate that again. Go straight away to the loading tab. You will notice that the imposed load is 20 kilonewton per meter square. And so if you have to impute your imposed load, you should first of all know the kind of vehicle that will ply in this particular bridge, and you will calculate the load and be able to apply the load through this imposed loads provision. And then you click on update. You do the same thing to all the slab, because the slab transfer the load to the beam, from the beam to the column, and the composite to the foundation. So this is how you can apply your imposed load. But for now, the imposed load we have is 20 kilonewton for this structure, depending on your site of implementation. Alright, so I'll be closing this right away, and before the analysis I'll go straight away to loading right there. I click on load cases and combination. In this provision I will be generating load not in the horizontal combination but in the vertical combination, because we are not considering wind load in this design. And so I click on OK to generate the load as I factor in my G and my Q. I click on OK. So after getting that done, if I want to add any additional load on this, I can as well use line loads. And for me to activate that, I go straight away to level 2, activate level 2 right there. And then I navigate to the plan view. I go to the loading tab right there. You can see point, line and area load. If I click right there in the dialog, I'll be able to select each of this load if I actually wish or actually want to apply an additional load. Alright, and so for instance I want to add like 5 kilonewton per meter square. I'll input it right there, and then I'll select a point on the slab, and then select the second point also on the slab right there to apply that load on the slab. Same thing applicable to this other slab. Do the same thing, apply the load just like that. If actually you cannot locate the center, you can press the control key on the keyboard to have a straight line, apply the load just like that. After which click on update and it closed. If you view this structure in 3D, navigate to the 3D, see the way the loads are being placed. As you can see it right there. So this is how you can also apply an additional load on the slab. Okay, so after having this done, we'll be looking at the analysis. But before that, we'll set the material. So go to the analysis tab right there. Click on building analysis. In the dialog, the pre-analysis can go to the project parameter. In the project parameter, you can be able to select your code of practice successfully, get to the foundations, and then change the allowable stress of soil. For the sake of this lesson, we'll have it as 50 kilonewton per meter square. And then you can also look at the title of your project. You input in the title successfully. For the sake of time, we'll skip this and click on OK. And then move straight away to the analysis tab. Go back to pre-analysis to set the material. Okay, Click right there. In the material, we have column as part of the structure, and we'll be considering this steel grade. This one, click on the rebar. For the column, you can choose to consider Y16 as the smallest and then Y25 as the biggest sizes of reinforcement. Alright, click on OK. Straight away to the beam, and then for your beam, you can do the same thing. Y16, okay, 20 and 25. The program may choose any of that reinforcement. Okay, that for the slab, you can also choose 12. You choose 10 right there, 12. You choose 16, and that is it for the slab. Click on the OK. For the links, consider 10 for the links, Y10 for the links. Alright, go straight away to the foundations, and also edit the foundations to be 12 and 16. 12 and 16, and should be having 20 right there and 25 mm for the foundation. Alright, click on OK. OK again. Okay, so at this point, you can now proceed to the analysis. But let us check once again the material, considering the walls, concrete walls, because we have wall there. Click right there in the diameter. We're having 10, we're having 13, we don't need 13, 12, and 16. You should have 20 and 25 right there for the wall, okay, which is the abutment. Click on OK. OK again. After editing the material successfully, you go straight away to the analysis tab. Click right there. We want to check the building. If there is any error, so you click right there and click on start. Building model check completed. Number of error is 1, so we are having number of error as 1. So let's load the log editor to check actually what is the error. You scroll down, you will notice that story 2, beam 2B2 and beam 2B2 have repeated level. These beams have repeated level. That is what is causing the error, and so we need to go and rectify that error. And how do we do that? Close this dialog, close this one, and close this. Do not run analysis since you're having an error. Okay, so click on close right there. Go straight away to level 2. This is level 2 right there, and then navigate to the plan view. And once you get there, they said beam 2B2, this one is having repeated level. This beam is having repeated level. So what we need to do right there is we have to delete this beam, this one. Click on the beam right there and delete it. So you can see there on the structural tree under beam, see 2B2 having 2 levels. So hold the shift key down and click the next one. Escape that. Select this beam and select this one as well. These two. Right click and delete the beams. So after having that done, we need to insert it again. So we just have to select any of these beam. Right click because it's of the same property. And pick this point. Pick this other point. To insert this beam. Just like this. Alright, so after having this done, click on closed. Alright, so if you check through the structural tree of the beam right there, you will notice that we are not longer having any repeated beam number right there. It's okay. We will proceed. Still check for error again if there will be any. After having this done, at first you need to save the project. So you click right there to save this project. Okay, we proceed to the analysis tab, and then we will carry out building model check again. Click on start. You can see the number of error is 0 now, so we have rectified that error. Click on closed. Go straight away to the analysis, building analysis. Click right there. We want the analysis to check the column force, reinforcement, as well as beam and the steel railing that we actually model. So you click on building analysis right there. So we're having a warning here. The warning has to do with the plane definition, actually, the inclined planes. That's what the program is telling us, that not all the slabs that are on the same level. That's why you're seeing this warning right here. Click OK. The building analysis is still in progress. We are still having all these warnings due to the plane definitions, okay, and the values. Click on OK. And the one in the analysis is successful. Click on closed. Now the program has transferred the structure to the analytical model. So you click on close right there to close this dialog. As the analysis is successful, we can see it check good right there. Click on closed. And this is the analytical model. So you can see in this analytical model, if I activate the displacement, so you can see the behavior of the beams in terms of their bending moment and the deflection. If I check the animations, you can see the movement of the loadings on the structure based on the movement of the structure based on the loading. To view the diagram, I click right there and activate M3, M33 to see the moment diagram of this structure. You can activate V3 right there, V2 to actually show you the shear force diagram, just like this. The next thing, you can also see the solid model, just like this. This is the solid model after analysis. For the M3, M33, you can check there, which is the bending moment. This is the solid model of that successfully. Okay, so after checking that, you can check for other things, the behavior and the graft, depending on where the movement is much. All these places where you are seeing red is where we needed to add more of the reinforcement. All right, I want to go back to the remodel, and I will navigate to the 3D right there. I still have this. At this point, my analysis is successful. So what I want to be doing now is I want to be inputting the foundation design. For the slab design, you can use a finite element analysis method of design for the slab successfully. But finite analysis method of design only considered a slab that is at the same uniform level. But this is not a uniform level slab. And so if you want to design this kind of slab using finite element analysis, you are going to consider it as at a uniform level so as to carry out the design successfully. For the foundation design, I will enable the story 0 by double clicking on story 0 right there. You can see the grid lines move to the foundation level. I'll select this column and right click to insert pie cap right there. But by then I'll be showing you the load that decompose to the foundations and the load that we are considering for the design of the pie. And for you to see that, I will navigate to the plan view, having activated the story 0 level. So this is the plan view. For you to see the load, come to these provisions, click right there. In this dialog, activate column plant display. Axial load, click right there and click in these provisions. Activate the dead load right there. Click on OK. OK right there and check the load. So this one, the load coming on this column is 311.2 kilonewton. This column is 313.8 kilonewton. This one 210.3 kilonewton, and for this one is 93.2 kilonewton. If you check the abutment, which is the wall, this is the load that's coming on it. This is 432.2 kilonewton, and for this is the same thing, 435.5 kilonewtons. So this is what we are having as the load that we are going to use to design the foundation. So being on the foundation level, we can just select the column, right click, and then click on the inside pie cap right there. Give the program some minute to insert pie cap after calculating based on the load that's coming to the foundation. So we are having about 9 piling point on the pie cap. As you can see, the design is successful. All the check has passed and design completed successfully right there. Click on OK to insert the pile right there. For this one, you do the same thing. Insert the pile cap. Also the same thing, because the load is not that differs. Okay. Click on OK right there. For this, right click and click on insert pie cap again. It's also the same thing, because the difference between the load that is coming to the foundation is not that much. And for this, you do the same thing. You're having this. Click on OK. Because the load that is coming on this is minimal. And so after inserting the pie cap successfully, sometimes the program allow us to insert pie cap under walls. But in some cases, when the wall is capable of withstanding the load, you will not be able to insert the pie cap under the wall successfully or as expected. So if you check it right there, you can see insert pie cap. It's not prompting. The reason is because the wall is capable to withstand the load that is coming. This load, 432.2 kilonewton, that is coming on the wall. The wall is capable of withstanding it, and so there is no need for pie cap under it. All right. So if you navigate to the 3D right there, it will have something of this kind. And so for the foundations, you have done it that successfully. You have run the analysis and designed the structure successfully. Alright, so if you now want to check the columns as well as the beam, if they have actually passed the design, you can go straight away to the structural tree at level 2 right there, where you have column, you enable it, click and right click and click on RC column was designed, this one, and do your interactive design. Click right there on the interactive design. The column is designed successfully. Click OK to have that. You can see the area approved and the area required successfully. So after After which, click on OK to get that design successfully. The same thing applicable to these ones. It's been designed now. Click on OK. And for this, do the same thing. OK that. Carry out the interactive design of each of the columns. This is the wall. Alright, click on OK. That has been designed successfully. The same thing here. Interactive design. Give some minute to calculate the moments based on the loadings. Right? Click on OK to have that design successfully. Alright, so all of this has been designed. So what you just need to do now is click on the close to close this dialog. If you want to view the reinforcement arrangement for the pie cap as well as the abutment, you can go straight away to the review tab right there. Click on that review tab. On the view, activate the view and click on the 3D rebar model. Once you click on that, it will take you to this provision. Activate the column reinforcement by clicking on the column. You zoom closely, this is the column reinforcement and the arrangement. Coming to the pie cap, you can see the returns. Activate the part footing bars to have the pie cap reinforcement arrangement, just like this. You can see. Alright, so the wall rebar, you activate the wall right there to have the wall rebar arrangement, just like this. So this is what we have. This is able to withstand the load that is coming from the beam based on the analysis result, and we are having this. Alright, so all of this has been designed successfully. In this provision we don't have beam, otherwise we could have shown you the beam rebar arrangement. Okay, so this is what we have in this version of Protastructure 2021, and we have carried out the analysis, design, and review the rebars arrangement successfully for this structure. You can transfer this to the Prota detail when you come to the drawing and report tab. Transfer it to the Prota detail. Click right there. It will transfer automatically to the Prota detail. If first you click right there and give the program some time, the result of what we have here will transfer to the Prota detail successfully. You can see the Prota detail loaded successfully right there. After loading is completed, you can proceed to auto-generate details. Click right there. In the draw detail dialog, just click on draw and pick any point on the scene area. It's going to draw all the parts of the foundation drawing, columns drawing, and the general arrangement drawing, as well as the reinforcements successfully. The drawing is completed, so if you zoom closely, you can see here. This is the bar arrangement for the columns. So the bar arrangement for the abutment, which is the wall. Right, the column sections. You can see the beam sections, just like this. Okay, so this is all the drawings that you will need to edit it to carry out the implementation of this design. Quickly, we failed to look at the beams. So let us quickly look at the beams. All right, so if I click on this beam, right click, and then click on the ROC design right there, you will have this. And whenever you're having your design, check good but in a red color, it means the design is not valid. You have to make it valid. It's only this first one that is valid. This one is not valid. Okay, we are supposed to do this before you transfer it to the Protastructure detail. So you just have to click on it and run interactive design, and then it will show that design is not valid. Do you want to update rebars? It's because of the rebars that make it invalid. So you just click on yes to update the rebar, and this will process and update the rebar successfully. In this provision where you're having 13, you can change it to 16. There, okay. You change the rebars to 16 and all of that. This is okay. Click on okay. So the same thing is applicable to the rest of the beams. So after that is done, you can proceed to transfer it again to Protastructure detail and get your drawing done and get set for implementation successfully. Alright, so I want to bring the lesson to a stop here. As we have successfully carry out the modeling, loading, analysis, and as well design and drawing productions for this mini bridge structure. We want to stop here. We look forward to continue in the subsequent lesson. Stay tuned. Like the lesson. If you have not subscribed, you subscribe. So each time I upload a lesson of this kind, you will get notified. Bye for now.